In this lesson, Exponential Growth and Decay Day 2, we are going to look at how we plug in different values and solve for the growth or decay. So in this, our A is our initial amount, or kind of our starting amount. And then our B is our multiplier. And that is our rate, if they give us a rate for that. And then our X is a lot of times our time in these examples here. But remember that B is greater than 1 when it's a growth, and B is less than 1, greater than 0 when it is a decay. All right, so for this first one, I'm going to go ahead and find A, B, and X, and then I will plug them into kind of this form so then we can solve it in our calculator. So we have a population of 35 bacteria. That is our A, starting amount. Then it doubles every hour. So doubling is our multiplier, which would be 2 when we double. Notice it's every hour. And then for 3 hours after that, we want to figure out what it is. So per hour, we end up with 3 hours, and that is our X. So Y equals, and then we put our A, 35 first, and then we put our B, which is 2, and then our exponent is 3. So in our calculator, we're going to take 35 times 2 to the third, and that is going to give us our answer of 280 bacteria. The next one, we have population of Brazil, which is A, our starting amount, 162,661. And then we have our B, growing at a rate of 7.7%. So remember, we have to change to a decimal. And then since it is a growth, we are going to add 1. Add the rate as a decimal to our 1. And so that is going to be a 1 plus 0.077 when we move our decimal 2 places to the left. And that is 1.077 for our B. Our X is going to be the amount of time. So it looks like we went from 1996 to 2016, but take note of your rate is per decade. So that is 10 years, right? So how many 10-year periods between 1996 and 2016? That is 20 years. Well, we would have 2 10-year periods, or 2 decades that have passed. So we're going to use 2 for our X. So let's go ahead and take 162,661 with 3 zeros times 1.077 to the second power in our calculator. And make sure that you try typing it into your calculator and double check that you got 188,675,211 people. And there was a 0.1, but we don't put 0.1 of people. We have whole people. All right, one more together, and then I'm going to have you try number 4 on your own. A, B, and X. Initial amount is 960. And then how much will be left after 30 hours if its half-life is 10 hours? So half-life, just kind of like double, but half. So our multiplier should be half. And then it's every 10 hours that happens. Well, it wants to know after 30 hours how much is left. So in a 30-hour period, how many 10-hour increments we would have? 10, 10, 10. So 3 10-hour increments. So we are going to use 3 for the x. 960 times 1/2 to the third power, and type that into our calculator to get our answer 120 grams. All right, try that last one on your own and then push play to check when you're ready. All right, double check that you got 2,000 people for number 4. And we're going to finish up day 2 on the back here with some graphing. So we need to find our y-intercept, and then we'll determine if it's growth or decay so we know which direction to graph. So to find the y-intercept, we want to have the x value be 0. X value 0. The horizontal asymptote, remember, is always our y equals 0. And so it will never go below that x-axis. So for our first one, we are going to plug in 0 for the x. So whenever anything is to the 0 power, it's 1, and then we'll just take that coefficient and multiply it times 1, and it gives us our y value, our y-intercept, 0, 5. So it's basically just going to be your a value, because every time you plug in a 0 here, it's going to make this into 1. And then it's just going to multiply times our a. So 0, 5, and we're going to plot that point. 1, 2, 3, 4, 5. And then we need to know which direction. So growth or decay, remember that we go back to our multiplier. And since that is a 0.25, that means that we are a decay. It's less than 1. So as we go from left to right, we should be going down. So this should be going down as we go to the right. And then this part was coming from the up. And that's it. We're done. So for number 2, if we plug in a 0, again, that's just going to give us 3 times 1, or 3. And our intercept is 0, 3. And so we need to now look at, are we a growth or a decay? So this being a 2 means that it is a growth. And so we're going to go up. And again, we don't ever go below our x-axis where our horizontal asymptote is. And then I want you to try number 3 on your own. Pause the video, try it, and push play to check when you're ready. All right, double check that you started with an intercept of 4 and it was a decay, so you should be going down as you go to the right. Last one has our little trick in there where it is the negative. So we need to, make sure my arrow is pointing kind of to it. There we go. We need to flip the multiplier. And that is flipping right here. 1 over 2 becomes 2 over 1. And then it becomes our positive x for the exponent. So 4 times 2 to the 0 is 4 times 1, or 4 for our intercept. And it is looking at 2 now, it is a growth. So we should be going up as we go from left to right. Oh, there's our asymptote dashed line.